about it. Remember that quiz is going to be about this topic and single displacement, the one where we see the activity series table. Okay? So, tell me, the first thing that we need to know is that we need to replace or to combine cations. Okay? Cations. Now, where is the cation in the first compound?
Calcium.
Just calcium, okay? And what is the cation in the second compound?
Potassium.
Remember the location of the cation. The cation is always the one in the left. And I know that I've said many times that the cation is an element, okay? It's a metal. But potassium, sorry, this is not potassium, by the way. This is phosphorus. This is a non-metal, okay? In acid, this is an acid. How do I know it's an acid? Because it begins with hydrogen. Okay, first. Second, acids are combined of, okay, in this case it's an oxyacid because it has a oxygen in it. So, oxyacids, what they have is the cation the cation in an acid is H plus. Remember that hydrogen is an element that can work in two different ways. It can be a cation and an anion. Hydrogen can be a H plus ion like in an acid, or hydrogen can be an anion like metal hydrides, for example. If I combine, let's say that I combine potassium with a charge of +1 and hydrogen with a charge of -1, yeah, the charges are cancelled. But how do we call this compound? In this case, as you know, as you can also see, the hydrogen element is at the end of the compound, and that is because that's not an acid. Okay, this is an ionic compound where potassium is the cation and the anion is hydrogen. Okay, so hydrogen like an anion. And the name of this compound is potassium hydride. In Spanish, hidruro de potasio. Okay? So, hydrogen is a very amazing element. That's why in the table of reactivity, the activity series table, hydrogen is not part of the non-metals. As you can see, hydrogen is located in a part of the metals. It says activity of metals, and you can see hydrogen in there. That's the reason, because hydrogen can be both. Okay? Take a look. Where is hydrogen? Hydrogen is here. Okay, hydrogen is here in the part of the metals, not in the part of the non-metals. Okay, because of that reason. So, in conclusion, do not forget acids have the cation of an acid is H plus, is the hydrogen part. The rest cannot be because this is what we know as the polyatomic anion. This is the anion phosphate. Okay, so this you cannot take any of these elements because of that reason. Anyways, so cation, we have calcium, and we have hydrogen in the case of, of an acid. Okay, just remember this is an acid, so we take hydrogen as as the cation. So what is going to happen is that we're going to change the position of the cations. Okay, So hydrogen is going to be combined with OH. Remember, the anion is going to remain in the same position. This anion is OH minus, okay? And the other one is going to be calcium instead of hydrogen, so it's going to be calcium, the cation calcium with a charge of 2 plus, and the ion phosphate, that is PO4, and the charge is 3 minus. Now take a look what happens here. H OH. When this occurs, when you combine H plus ions with hydroxide ion, this forms what we know as water. So anytime you see the H plus combined with OH, what you have actually is water. And the formula you already know it is H2O. Okay? Now this other formula, what we need to do is crisscrossing the charges. So the 2 goes to phosphate to affect all phosphate, and the 3 comes to affect all calcium. So you will have calcium, the 3 that is coming from phosphate, and then you will have phosphate and the 2 that is coming from calcium. Wait.
The parentheses.
Yeah, I'm missing the parentheses, so I put them here. Sorry, this thing is a little bit slow today. So you're gonna see the parentheses like in a minute. Sorry about it. Oh, yeah, there it is. So this is the reaction. This is the product of the reaction between calcium hydroxide and phosphoric acid. I'm just going to write it again. And then we see if it's balanced, okay? As you can see, it's not balanced. I'm gonna put it beside better so I can balance. Okay? Now all I do is, I don't know if you want to balance this, but anyway, I will do it. Is that sometimes I think that I spend too much time in balancing reactions, and that's not the topic. Anyway, remember the elements listed: calcium, phosphorus, oxygen, hydrogen, and then, well, the amounts. Okay, here I have 1, I have 5 and 1, I have 2 and 4 is 6, and here I have 2 and 3 is 5, here I have 3, here I have 2, here I have 9. Who said oxygen and the hydrogen? Anyway, así lo voy a dejar. I don't like it. I don't like it.
This is one.
But así lo dejo.
4 times 2 and 1.
Yeah, and hydrogen is gonna be just 2. Okay, to balance, I will start balancing calcium by placing 3. Now I have 3. Okay, it changes my hydrogen. Now I have 6 and 3, I have 9 hydrogens. And it changes my oxygen. Now I have
10.
exactly 10. And then, because I have 2 phosphorus on the other side, I put 2 here. My phosphorus is balanced now, but also changes my oxygen and hydrogen. Oxygen now is going to be 8 plus 6, 14, And in the other side, it's going to be 6 plus 6. We're going to have 12 hydrogens. Okay? So here to balance, I'm going to place just 6 to balance. Let's see. Now we have 12 hydrogens. And about oxygen, I have 6 and 8, 14. So now the equation is balanced. So as you can see, the procedure is same procedure.
You didn't put the H before phosphate because we converted in water, right?
Exactly. It is converted to water. So every time you see this, every time you see H plus and OH combined, just write water instead. It's the same. Any doubt on this exercise? Any doubt on this exercise? This is how I'm going to work, okay? I'm going to write the products here, but my final answer in the other side, okay? Next. Now here, what am I going to combine? Or what's the cation? What's the cation of first?
Potassium.
Potassium.
Potassium and beryllium.
Yeah, like the avocado, potassium. And barium.
Barium.
I think I heard beryllium. It's barium. If I misheard it, sorry. Okay, so you combine them. So you will have barium. The charge is +2. Okay. Combined with CO3. The charge of CO3 is 2 minus.
Only cancel.
Mm, exactly, I cancel the charges. Now, in the other side, I have potassium, which has a charge of +1,
1.
and I will combine it with CO, okay, with chlorine. Chlorine as an anion is the ion chloride, which has a charge of -1. So what happens here, again, the charges are cancelled. So I can write my expression like this. And now all I do is to check if it's balanced. Potassium and barium go first, then chlorine, carbon, oxygen. I have 1, 1, 2, 1, 3. In the other side, I have 1, 1, 1, 1, 3. So it's not balanced. I place 2 in front of chlorine. It affects my potassium and also chlorine. And then, potassium I had 2 in the beginning, sorry. It wasn't 1, it was 2 directly from the beginning. And now my equation is magically
It's
balanced.
balanced.
I was thinking, how am I going to balance potassium? But anyway, it was good. So as you can see, guys, this procedure is very, very simple. But still, it's something that requires its own practice. It is good that you guys know that, okay? That you guys know about charges, that you guys know about cross-crossing charges, that you guys know about reducing, simplifying charges. So it is important. This topic is very much important. And it's so related to compound formation. It's a topic that I always say, that I always explain how to crisscross the charges because it's important. So that will be it. Okay, this one is very much interesting. What is the cation in the first compound?
Cadmium.
Cadmium.
Cadmium. What is the cation in the second compound?
Sulfur.
No.
Nitrate.
This one is nitrate. This one is a polyatomic anion, but it's a cation.
Ammonium.
It has a charge that is +1. That is ammonium. ¿Ok? Ammonium es un cation, chicos. Así que, siempre que lo vean, no. It is a cation, not anion. Y luego cadmium, bueno, cadmium has a charge of +2. Está debajo de silver, if I'm not mistaken. Si no está abajo, está arriba de silver. In the same column. Okay, so now that you have already identified the cation, all you have to do is change the position of them. Okay, that means that ammonium is going to be combined with the anion PO4. Okay, PO4 is phosphate and it has a charge of -3. So what's going to happen? This charge, ignore it, the charge of +1, you can ignore it, but you have to crisscross the charge of 3. Okay, so in the end, you will have NH4, the 3 that is coming from phosphate, and then you will have phosphate. Am I missing something? Parentheses, okay? Here and here. As you can see, the parenthesis is not always in the in the right part, but it's always if the polyatomic ion is affected by the other charge. So anytime you crisscross a charge to a polyatomic ion, it's going to affect the entire ion, not just one single element. In the other side, you will have cadmium combined with cadmium, which is +2, combined with S. Sulfur alone works like an anion, and it is the anion sulfide, and it has a charge of -2. So here is pretty much the simplest thing, which is just cancel the
Cancel.
charges. So the compound formed was this. Okay. Now I just need to rewrite my expression again. So I will have cadmium phosphate and ammonium sulfide. They are combined to produce, well, the product that we just got. NH4 and cadmium sulfide. All you need to do after is checking that it's balanced. So you will have the metal first, and then the non-metals. So here I have 3, here I have 2, here I have 2, 1, 8, 8. In the other side I have 1, 1, 3, 1, 12, and 4. Okay,
60.
obviously not balanced. Okay, obviously not balanced. So my phosphate in this side, take a look what I'm gonna do. My phosphate here is being affected by 2. So in the other side, I will put 2 where my phosphate is. Okay? Here, my ammonium is being affected by 2, and here is being affected by 3. Okay? So there I crisscross the charges. So here I'm just going to place 3. Okay? And to balance cadmium, I'm going to place 3 there. Supposedly, it's already balanced, but I need to check. So that's how I do it mentally, but now I have to check. Never trust myself on balancing this way, but it's good. It helps me. So I have 3 cadmiums. Now I have 2 phosphorus. Now I have 6 nitrogens. Now I have 3. Now I have 24.
Or
A hydrogen 24, and oxygen is gonna be 28. Okay, in the other side I affected this part only, so I'm gonna be affecting nitrogen. Now is 6, sulfur now is 3, and hydrogen now is 24, and now it's balanced. That's how I do it, guys. All I see is phosphate affected by 2. I need to multiply this phosphate by 2. Okay. Now this part is a little bit more complex porque tengo un ammonium y 3 en el otro lado. Ok. Y aquí tengo ammonium times 2. Entonces yo lo que hago es I crisscross the coefficients. El 2 lo paso para el otro lado, like I did there. And the 3 I put it in this other side. Eso es lo que yo hago, like mentally. Y luego, pues, obviamente, el cadmium needs to be multiplied times 3 to balance. Pero, okay, basically that's how I do it. How it's balanced. Yeah, I know it takes time to do that. Yeah, ustedes en su cuaderno van a trabajar con este ejercicio. Bueno, ustedes en su cuaderno, you're gonna work in this exercise. Ya saben, ¿ok? Que cuando combinen age and old age, tienen que hacer algo especial. You're gonna work in this one. With this, we can say the conclusion that whenever you combine with hydrogen and hydroxide, water is going to be formed. That's something that we can define. When you combine hydroxide with acid, you're gonna form water, just like it's going to happen here. You have hydroxide here, and you have an acid in the other side, so yes. So right now, work in this exercise in your notebook, and you send it to me and to check it, okay? I'm just going to check that you did it right. Whenever you have it, you send it to me in the chat or in WhatsApp. Guys, do not stop doing your assignments this week because this week and last week were 20% each, okay? So each assignment is very expensive for that thing, so do not miss anything. If you miss it and you still want to send it again, you can, but it's going to be for less points. En el caso de cobalt is a transition metal, ¿ok? Cobalt trabaja con diferentes oxidation numbers. ¿Con qué número está trabajando cobalt ahí?
+3.
Plus 3, ¿ok? Entonces en el producto también cobalt tiene que trabajar con 3, ¿ok? Whenever you have it, you send it to me in the chat